So here's another composite function problem. At a restaurant on the Maine coast, the supply of fresh new shell lobsters during the season is given by the function L. The supply, that has to do with how many lobsters we have, okay? Keep that in mind because down here, it's talking about the restaurant having X lobsters, okay? So this definitely would have to do with how many lobsters we've got going on here. But what it's asking for is a function that gives the price per lobster, okay, in terms of the number of days after July 1st. So how do we know, are we plugging the C function into the L function or the L function into the C function? Well, the C function is the cost function. That's what we are looking for. We're looking for the price after a certain number of days. So if we start with the C function and we know that we are looking for the cost, X, remember X was talking about the number of lobsters? Here, this has to do with the number of lobsters. So what we're going to be looking for is the lobster function. We're plugging the lobster function, and it did say in terms of the number of days, so that's where our T is coming from. So our lobster function is going to go into the cost function. So we start out by writing the 37 minus empty set of parentheses where the X is, empty set of parentheses, and then what goes in there? The whole lobster function. Okay, so we have negative 0.006 t squared plus 0.733 t. And that's the cost function having plugged in the lobster function. Now we can just simplify this and it will look like this if we write it in descending order of the variable, which is a good way to write it. 0.006 t squared minus 0.733 t plus 37. I just used the distributive property here and simplified it. So the entire function written correctly is going to look like this.